Dear students, I welcome all for this session. In our previous session, we have discussed about linear queue, and now we will discuss the main drawback of linear queue. Let us consider a linear queue as shown in this figure. So the size of the linear queue is 5, and initially 5 elements were inserted into this queue, and the rear pointer is pointing to an index location 4. After performing two deletion operation on this linear queue, the front pointer is moved to an index location 2. Now the front pointer is pointing to an element 11. In this scenario, there were two memory locations which are empty, but still you cannot insert any element into this location. The array implementation of linear queue does not utilize the allocated memory efficiently. Here, we cannot insert items into the queue even if there are free memory space in the beginning of the queue as shown in the above diagram. And this is the main limitation of linear queue. To overcome this drawback, a new data structure was introduced and it is called as circular queue. A circular queue is similar to linear queue as it is based on first in, first out principle, except that the last position in the circular queue is connected to the first position. Hence, it forms a circle. Because it forms a circle, circular queue is also called as ring buffer. Let us consider an example and analyze how the circular queue will be implemented. The circular queue will be implemented using a one-dimensional array as like the linear queue. And this diagram illustrates the concept of circular queue. So there were 6 elements in this queue. The size of the circular queue is 8 and the elements were inserted into this circular queue. Now the front pointer is pointing to the first element, that is 10, and the rear pointer is pointing to the last element, that is 25. Still, there were 2 memory locations empty. You can insert another 2 elements into this circular queue. Here you can notice the last and the first location in the circular queue are considered as neighbors. Hence, it got the name circular queue. Okay. Now let us see some of the applications of circular queue. Circular queue is used mainly in memory management, and priority CPU scheduling algorithm uses circular queue, and the traffic system uses circular queue. Let us now discuss how to perform insertion operation in circular queue. Initially, have considered an empty circular queue where front and rear pointer is pointing to -1. To insert an element into the circular queue, as like linear queue, you are going to increment the rear pointer. Since you are inserting the first element into the circular queue, you are going to increment both front and rear pointer. So now the front and rear pointer is pointing to an index location 0 and the element 23 is inserted. Similarly, by incrementing the rear pointer, you are going to insert other elements into the circular queue. Okay, so now the last element, that is 67, is inserted into the circular queue and the rear pointer is pointing to an index location, that is maximum size -1. The maximum size of the circular queue is 5. 5 minus is 4. That is the index location of the rear pointer. So when the rear pointer reaches maximum size -1, it clearly indicates that the queue is full. So in this situation, no further insertion is possible. You have to stop insertion operation. Okay. Let us now delete one element from this list. How we are going to delete an element from the circular queue? Just you are going to increment the front pointer. Now the front pointer is pointing to an index location 1. It means the previous element was deleted. Okay. Now in the circular queue, one memory location is free. Here to this memory location, that is to the first memory location, it is possible to add an item. We can add one element to this position. But the question is how to move the rear pointer to this location 0. The answer for this question is here in circular queue, we are not going to increment rear pointer by the formula rear equals to rear plus 1. Okay, so this is not at all helpful in circular queue. Hence, we are going to use rear equals to rear plus 1 modular division of maximum size. So when you use this formula, the rear pointer can be moved from this last index value to again back to first index value. Let us now discuss how this incrementation is done with an example. As I have told you, to move the rear pointer from the index location 4 to the 0th location, we are going to use the formula rear equals to rear plus 1 modular division of maximum size. So when you substitute the values for these variables, you will get 4 plus 1 modular division of 5. So that is 5 modular division of 5. So when 5 is divided by 5, the remainder will be 0. So now the rear pointer will point to an index location 0. So this formula, you will use it for incrementing the rear pointer. Suppose if the numerator is lesser than the denominator, then the modular division operator will return the numerator itself as the remainder. Okay. So using this formula, you're going to increment the rear pointer. Normal incrementation operation will not be helpful in case of circular queue. Let us now discuss when the circular queue is going to be full. Circular queue becomes full when any one of the following conditions are satisfied. These two conditions are diagrammatically explained here. When the front pointer points to 0 and the rear pointer points to maximum size -1, that is the last index value in the circular queue, then you can clearly say that the queue is full. That is the first condition. When both these pointers are matching these conditions, then you will say that the queue is full. In the second case, the rear pointer is just one step behind the front pointer. Even in this scenario, the queue is going to be full. Hence, you will check for this condition. If the front pointer is greater than 0 and the rear pointer is front -1, just one step behind the front pointer, then you will say that the circular queue is full. These two conditions you have to check before performing any insertion operation in circular queue. Let us now discuss a C program segment for performing insertion operation on circular queue. The enqueue function here accepts an integer item which is going to be inserted into the queue. Before inserting this item into the queue, you will check whether the queue is full or not by checking both the conditions that we have discussed in the previous slide. If any one of the conditions are true, then the queue is going to be full and the insertion operation is not going to be taking place. Okay, hence you will say queue overflow. If the queue is not full, then you will check whether you are performing insertion operation for the first time. If you are performing insertion for the first time, along with the rear pointer, you're going to move the front pointer, right? So if front pointer is equal to -1 and you are performing insertion, then you will set this front pointer to 0. And in the next step, you will increment the rear pointer by the formula that we have discussed in the previous slide, that is rear equals to rear plus 1 modular division of maximum size. Okay, and then to this rear position, that is a clear queue of rear position, you are going to insert an item. After inserting an item, here I am printing a message that is item inserted. So this is a simple enqueue function for inserting an item in circular queue. Okay. Now, let us discuss how to perform dequeue operation in circular queue. Here I have considered the same queue that I have created earlier. Now, in this queue, the front pointer is pointing to an index location 1 and the rear pointer is pointing to an index location 0. To delete an item 9, now you are going to move the front pointer to the next location. Similarly, you can delete the other elements from the circular queue, that is 11, 55 and 67. After deleting the element 67, the front pointer has to be moved from the last index location to the first index location. That means normal incrementation of front pointer is not going to be helpful in case of circular queue. Again, you are going to use the same formula that we have discussed for incrementing the rear pointer. In place of rear, you are going to put front variable. That is front equals to front plus 1 modular division of maximum size. In that, if you use that formula, you will bring that front pointer from the index location 4 to the index location 0. Now, the front pointer is pointing to an index location 0, that is the last element in the circular queue. After deleting the last element from the circular queue, you have to set both front and rear pointer to -1, which indicates that the queue is empty. This condition you have to remember when you are deleting the last item from the circular queue. You have to set the front pointer and rear pointer to -1. So how you will come to know that you are deleting the last element? Just look at this scenario. Here both rear and front pointer are pointing to the same index value. When both front and rear pointer are pointing to the same index value, that it means you are deleting the last element. In that case, you have to set front and rear pointer to -1. Let us now discuss a C program segment for the Dequeue function. Before deleting an item, you are going to check whether the queue is empty or not. By checking this condition, front equals to -1. If the front pointer is pointing to -1, it clearly indicates the queue is empty and you cannot perform deletion operation. Else you are going to delete the element that is pointed out by this front pointer. Okay, the deleted item will be circular queue of front, and I'll print the message that the deleted item is this, which is pointed out by the front pointer. And how you are going to move the front pointer? You are going to move the front pointer from one location to the next location by using this formula. Front equals to front plus 1 modular division of maximum size. Okay, if you are deleting the last element, see, as I've told you in the previous slide, if both front and rear pointers are pointing to the same index location, it means that you are deleting the last element. When you are deleting the last element, you have to set this front and rear pointer to -1. So this is the C program segment for Dequeue function. Let us now discuss how to display the elements of the circular queue. Here I have called a display function. Before displaying the elements, make sure your list, that is circular queue, is not empty by checking a condition, that is front equals to -1. If front equals to -1, it clearly indicates the queue is empty and there are no elements to display. Else you are going to display the elements from the front pointer to the last pointer by incrementing the I value by I equals to I plus 1 modular division of maximum size. Okay. After printing the elements of the circular queue, you are going to close the display function. Let us now discuss another data structure, that is double-ended queue. Double-ended queue is a queue in which insertion and deletion takes place at both the ends of the queue. If you can insert and delete elements from both ends of the queue, that is from the front end and rear end, we call such queue as double-ended queue. Some of the applications of double-ended queue are as follows. Undo and redo options in many software applications uses this Dequeue, that is double-ended queue. In web browser history, to store recently visited sites URL, you use double-ended queue. URLs are added to the front of the queue and URLs at the back of the dequeue is removed after some time. Let us now discuss the next data structure, that is priority queue, the next type of queue. Priority queue is a queue to which elements are added and deleted from any positions. Elements are added into the queue based on the priority, and elements are also deleted from the queue from any positions based on the priority. Some of the applications of priority queue are as follows. Priority queues are used in priority CPU scheduling algorithm, and first come first serve CPU scheduling algorithm also uses priority queue, and the printer systems also uses priority queue to store jobs. The higher priority jobs are printed by the printer and the lower priority jobs are the printing of lower priority jobs are delayed for time being. So that is how the printer uses the priority queue. And the multi-programming platform systems also uses priority queue. Even the PRIMS algorithm uses priority queue. In this class, we have discussed circular queue, operations on circular queue, and we have briefly discussed dequeue and priority queue. And we have briefly discussed doubly-ended queue and priority queue. With this, I'll conclude the session. Thank you.